Welcome to the Aarna.ml GPU Cloud Management Software Demo, where we will be showcasing a complete end-to-end PaaS experience. Ara.ml's GPU CMS helps enterprises in their complete AI/ML development lifecycle, right from model development, training, and hosting it in production, all while ensuring optimum GPU utilization and supporting multiple projects, teams, and internal departments. In the use case demonstration that you will see, we shall be using two tenant personas: the tenant admin, who is responsible for their organization's overall resource and user management, including setting quotas and curating the available services; the tenant user, who is the end consumer, such as a data scientist or ML engineer, who accesses the self-service portal to run their specific AI workloads. This multi-level approach allows enterprises to deliver a secure, governed, and agile service to their end users. First, let's see how easy it is to deploy a trained model and then consume this model in a model inference as a service mode. Our first use case features Summit Mart Inc., a large retail chain. Their customer experience division wants to launch an AI-powered chatbot to handle thousands of customer inquiries daily, without managing the complexity of GPU infrastructure. Summit Mart's tenant admin, Jennifer Collins, will use aarna.ml GPU CMS to roll this out quickly. Let's follow Jennifer, an enterprise MLOps engineer, as she sets up the service. First, Jennifer logs into the aarna.ml self-service portal. You can see available models in the catalog. We have already onboarded 2 servers and have created a cluster. Jennifer first creates an endpoint to access inference service by specifying the endpoint name, description, hostname, cluster that shall host the endpoint, and TLS configuration. Now that endpoint is created, Jennifer browses the model catalog and selects a curated, pre-optimized Qwen Foundation model, available via Hugging Face. With the model selected, she can now deploy it instantly, specifying model name, description, Hugging Face token, endpoint, GPU type, GPU count, auto-scaling parameters such as min and max replicas, auto-scaling trigger based on number of pending requests. Defining scaling limits ensures that the costs remain predictable, even under peak loads. Next, Jennifer sets the governance and commercial policies. Jennifer configures token-based rate limits so the service won't be overused. This allows for precise financial tracking. She sets chargeback and showback rates, allowing finance to track AI consumption per department. With all these inputs, she deploys the model as a scalable inference service. In the background, the platform is doing the heavy lifting. Aarna.ml handles all the heavy lifting: containerization, GPU allocation, and generating a secure serverless API endpoint, and the result is a production-ready service, ready in moments. Within minutes, the chatbot service is live, without Jennifer touching Kubernetes or GPU drivers. Lastly, Jennifer creates an end user, David Miller, who shall be consuming this model inference service, end user workflow, consuming the service. Now let's switch to the end user, David Miller, a developer on the customer support team. He sees the previously deployed model in his catalog. To access it, he needs to generate credentials. David generates a secure API key to authenticate against the inference endpoint. With the key in hand, he can connect it to their application. The chatbot is now live and serving requests. David tests the model using the playground feature by sending some sample queries to the model and ensuring he receives real-time responses. He also verifies that the token consumption is being updated. Now that the service is tested, David plugs the API key into Summit Mart's help desk application, and all the support personnel are able to use this custom chatbot service. Finally, David can track the service's performance from his dashboard. David tracks token consumption and performance metrics on a live dashboard to ensure smooth scaling and budget compliance. The results speak for themselves. Jennifer, the admin, launched a production-ready inference service in hours, not weeks. The support team now relies on a highly responsive AI chatbot, improving customer satisfaction. And for Summit Mart, their AI infrastructure runs securely and at scale with full cost control, enabling faster innovation. Now let's see the next use case that focuses on the development of AI/ML models. Horizon Bank is building a new AI-powered recommendation engine. The data science team needs to track experiments using MLflow, and they've asked their tenant admin, Michael Reynolds, to provision a secure environment. Tenant admin workflow, preparing the foundation. Michael, AI/ML project lead, begins by preparing the foundation for his data science team. Michael logs into the aarna.ml GPU CMS portal and starts with allocating bare metal servers to begin with. Next, Michael initiates the creation of a new cluster dedicated to the data science team. For this, he navigates to the cluster creation flow for creating a Kubernetes cluster from allocated bare metal servers. As part of this flow, cluster name, description, Kubernetes version, CNI plugin, nodes to be part of the cluster are provided. Kubernetes cluster is created, which Michael then verifies. Finally, Michael creates the end user, Sarah Johnson, an ML engineer in the system who shall then use the Kubernetes cluster for AML development. End user workflow, deploying the application. Now we switch to Sarah Johnson, an ML engineer on the team. Sarah Johnson, an ML engineer, logs into her aarna.ml dashboard and sees the newly provisioned Kubernetes cluster. She can now access the tools her admin has prepared. Sarah navigates to the software catalog where prepackaged Helm-based applications are listed, and she finds exactly what she needs. She selects MLflow from the curated catalog. Deploying the application is just one step. With a single click, Sarah deploys MLflow onto her private cluster. The platform handles the underlying complexity. The deployment completes without her writing a single YML file or managing Helm directly. Now she can verify and share the new service. Sarah launches the Kubernetes console directly from the aarna.ml UI. From the console, she verifies that MLflow is running, copies the service URL, and shares it with her team. The team is now ready to begin their project. The data science group now has a fully managed, private MLOps tool for their recommendation engine project. From the console, the team is now ready to begin their project. For Michael, the admin, he provisioned an isolated Kubernetes cluster and curated a software catalog in minutes. For Sarah and her team, they gained a self-service MLOps environment instantly, with no DevOps bottlenecks. And for Horizon Bank, their AI team can now accelerate model experimentation securely within a governed enterprise environment. Finally, let's see how GPU-optimized scheduling is taken care of. Novatech Labs is developing a cutting-edge computer vision model. Their research team needs an interactive environment with guaranteed fair access to GPUs. Their tenant admin, Laura Mitchell, will use aarna.ml to provide this. Tenant admin workflow, enabling advanced scheduling. Laura starts by deploying a new cluster for the team. Laura logs into the aarna.ml GPU CMS portal, allocated bare metal servers, and deploys a dedicated private Kubernetes cluster for the research team. To provide the fairness and performance they need, she enables a key feature. During cluster setup, she selects the template with Jupyter Hub and initiates the deployment on Kubernetes cluster. The platform handles all the complexity. Under the hood, aarna.ml handles the full deployment of KI onto the cluster, along with deployment of the Jupyter Hub on Kubernetes with no manual installation needed. Next, she onboards the researcher, Ethan Brooks, as an end user. Now we see the researcher, Ethan Brooks, begin his work. Ethan Brooks, an AI research scientist, logs into the aarna.ml self-service portal. He can access his development environment directly from the platform. He launches his Jupyter Notebook environment, which is integrated directly into the CMS. He can now work within the familiar Jupyter interface. From the familiar Jupyter interface, Ethan writes his model training and testing code, and the platform intelligently manages the backend. His jobs are automatically routed to the KI scheduler behind the scenes. KI ensures his job is placed on the best possible resource. KI analyzes GPU topology, utilization, and workload priorities, then places Ethan's job on the most optimal GPU resource. This results in a superior user experience. Ethan experiences a fast, responsive notebook session where experiments run smoothly, and his interactive work is protected from other large jobs. Thanks to KI's fair share scheduling, his work isn't blocked by other teams' long-running jobs. The ultimate result is faster innovation. The team iterates on their vision models much faster, moving research to results in record time. For Laura, the admin, she enabled a controlled, policy-driven GPU environment in minutes. For Ethan, the researcher, he gained a snappy, interactive development environment with guaranteed GPU access. And for Novatech Labs, research productivity accelerated with GPU resources shared fairly, allocated intelligently, and fully governed. While you saw how easy it was to utilize the PaaS features using aarna.ml, GPU CMS, what happened under the hood was complete AI infrastructure provisioning and secure hard isolation between various tenants across 7 pillars, comprising the CPU, GPU, Ethernet fabric, InfiniBand fabric, NVLink, external high-performance storage, and external gateway. All this was performed by aarna.ml GPU CMS, followed by PaaS deployment on top of a secure AI infrastructure. Let's take a look at the magic under the hood. Logan as an AI infrastructure admin. Discover the AI infrastructure in an automated manner and view all the discovered components comprising of CPU plus GPU compute nodes, network fabric, storage devices, and external gateway. You can see the interrelated topology view of various compute nodes, multi-tier switches, storage nodes, undelay networks, etc. Now create the tenant admins for Summit Mart, Horizon Bank, and Novatech organization. Subsequently, these tenant admins create respective end users. Every tenant gets an isolated and a secure compute and network across east-west and north-south networks. On this solid foundation of secure and isolated AI infrastructure for every tenant, the PaaS is layered on top. This is how aarna.ml guarantees a robust, secure, and truly multi-tenant experience, from the silicon all the way up to the application.